Доброе утро, добрый вечер, дамы и господа. Это Центр управления полетами Korolyov. Good morning to everyone around the world. This is Mission Control Korolyov. You're looking at a live picture of a Russian Proton rocket poised to deliver to space the next major piece of the International Space Station, the Zvezda service module. Zvezda, the Russian word meaning star, is 26 minutes away from being launched on a path that will take it to its permanent home 14 days from now. The actual launch time is 8:56 and 36 seconds this morning Moscow time. That's 10:56 local time at Baikonur Cosmodrom in southern Kazakhstan. The 42,000-pound Zvezda was mated to its Proton rocket 5 days ago, and this past Saturday morning was transported by rail car to Launch Complex 81. Baikonur is home to many historic launch pads which dot the landscape of the sprawling complex, which measures 95 by 75 kilometers. But Zvezda's journey to the International Space Station began long ago on the drawing boards of Russia's aerospace engineers, who designed it to be the first piece of that country's newest space station, a follow-on to Mir. When Russia joined the International Space Station project in 1993, Zvezda became the centerpiece of the Russian segment of the complex and its early living quarters. After reaching the pad, the Proton rocket was raised vertically for the final preparations for launch. The 3 stages of the Proton use a combination of asymmetrical dimethylhydrazine and nitrogen tetroxide as their propellant. The first stage has 6 liquid rocket engines that will burn for 2 minutes 6 seconds. The second stage combines the thrust of 4 liquid rocket engines that will fire for about 3 minutes 28 seconds. And the third stage has 1 liquid cruise engine that will burn for 4 minutes 3 seconds. Once the final stage has completed its job, Zvezda will be in an initial orbit of 214 miles at its high point and 108 miles at its low point. That's 343 by 173 kilometers. Additional engine firings will occur during the next 2 weeks to place Zvezda at an altitude closely matching that of the International Space Station. At the time of Zvezda's launch, the International Space Station will be flying high above the Solomon Islands over the Pacific. Once in space, Zvezda's thruster jets will perform numerous maneuvers to adjust its orbit in relation to that of the International Space Station. Leading up to docking, the 2 spacecraft will perform a dual rendezvous, meaning that engine firings are conducted by both spacecraft to refine their positions in relation to one another. About a month from now, an unpiloted Progress cargo ship will be launched atop a Soyuz rocket, delivering more supplies that will be used by astronauts and cosmonauts as the complex grows in size and capability. The Proton rocket, with Zvezda cocooned inside a protective shroud at the top, stands about 180 feet tall. That's about 55 meters. This type of launch vehicle has been used for heavy lift launches of Russian satellites since 1965. Today, the rocket, built by the Khrunichev State Research and Production Space Center, continues the complex task of putting the International Space Station together. On the scene at Baikonur awaiting Zvezda's launch is NASA's Rob Navius, who filed this report earlier.
Here at this legendary site in the Central Asian desert, all is in readiness for the launch of Zvezda just a few minutes from now. Several miles away from our viewing site is the launch pad from which Yuri Gagarin was launched almost 40 years ago to become the first human to fly in space. Today, with temperatures approaching 100 degrees Fahrenheit, the Russian space program begins a new chapter with the launching of the service module. We are located at Launch Complex 81 here at Baikonur, about 3 kilometers or a little less than 2 statute miles from Launch Pad 23, where the Proton sits fully fueled awaiting its liftoff. Here at the viewing site, a large group of officials and dignitaries are on hand, including NASA Administrator Daniel Golden, NASA's Associate Administrator for Spaceflight Joe Rothenberg, Johnson Space Center Director George Abbey, and Kennedy Space Center Director Roy Bridges. Russian Aviation and Space Agency General Director Yuri Koptev leads the Russian delegation here at Baikonur, along with the chief designer of the service module, Yuri Semyenov of RSC Energia. Other heads of agency involved in the International Space Station program are here as well, along with ISS Program Manager Tommy Holloway and astronaut Bob Cabana, the Deputy Manager for International Relations, who commanded the first ISS assembly mission in December 1998. And here to watch as Zvezda begins its journey are Tom Stafford and Vance Brand, the commander and command module pilot of the Apollo capsule for the Apollo-Soyuz test project, which began international partnership in space on July 15, 1975, almost 25 years ago to the day. That's it from Baikonur as we await launch, Kyle. Back to you in Korolyov.
Now just 21 minutes and 20 seconds away as the countdown clock continues to this morning's launch of the Zvezda service module. Some of the milestones in the final hours of today's countdown have included the activation of Zvezda's internal systems for final health checks, including the module's radio communications system, the thermal control system, and the motion control system to provide stability for Zvezda in orbit. About 6 hours ago, the 3 stages of the Proton rocket were loaded with propellant, which has been replenished and topped off over the past 2 hours. About 40 minutes ago, updates to the Proton's onboard computers were sent in pre-programmed commands, and just 20 minutes ago, launch officials initiated a timing device governing the final major events that lead up to the Proton's launch, again at 8:56 this morning Moscow time, 10:56 a.m. Baikonur time. Zvezda's initial development and construction was performed by Khrunichev, with most of its assembly and checkout conducted by Rocket Space Corporation Energia, located here in Korolyov near the Russian Mission Control Center. Zvezda serves as the first fully Russian contribution to the International Space Station program and will provide the living quarters necessary to put humans on board permanently later this year.
The origin of Zvezda, the third component of the International Space Station, dates to the early 1990s, when NASA, the European Space Agency, and the space agencies of Canada and Japan were planning a new space station. Russia was also laying the groundwork for a space station to succeed its Mir space station. As those designs proceeded, NASA brought the newly formed Russian Federation into the global partnership, with Zvezda to be the first fully Russian contribution to the International Space Station. Zvezda's layout is similar to the core module of Mir. The Khrunichev State Research and Production Space Center in Moscow began construction on the service module in 1991 for the Rocket Space Corporation Energia, which will operate it on orbit. In June of 1998, Khrunichev announced completion of the module and transported it across town to Energia, where it began sensitive system testing. In April 1999, in front of a large group of dignitaries, the service module was unveiled for the entire world to see. Shortly thereafter, it was placed on a special rail car for the 1,200-mile journey to the Asian launch site at the Baikonur Cosmodrom for final testing and launch preparations. Designed for an on-orbit life of up to 15 years, Zvezda is 43 feet long, more than 97 feet across from the tip of one solar array to the other, 21 tons of hardware that will ride to Earth orbit atop a Russian Proton rocket. Zvezda contains one docking port in the aft transfer chamber, where Soyuz and Progress ships can dock, and 3 docking ports around the forward transfer chamber, one to link with the aft end of the Zarya control module, and 2 more for other Russian-built components of the station due to arrive later in the station's assembly sequence. The transfer compartment will also serve as an airlock for spacewalks using the Russian Orlan spacesuit. Between these chambers is the heart of Zvezda, the main work compartment. Here, long-duration crew members will have personal sleeping quarters, complete with toilet and hygiene facilities, a galley with a refrigerator freezer, and a communal table for meals, exercise equipment, and a choice of 14 windows through which they can watch the Earth and the stars pass by. In this compartment, crew members will find the workstations to control ISS's life support system, its electrical power distribution and data processing systems, the flight control and propulsion systems, and communications with mission control centers in Houston and Korolyov. Many of the control, guidance, and navigation functions are handled by the European Space Agency-supplied data management system. This month, perched atop a Russian Proton rocket, Zvezda was rolled to the launch pad at Baikonur for the final countdown.
Back at the launch site at Launch Complex 81 at the Baikonur Cosmodrom, the Proton stands ready for launch as officials conduct additional checks of its onboard batteries, having just completed a realignment of the rocket's trajectory control system. In a few minutes, Zvezda's telemetry systems will be activated and monitoring of the Proton's thermal systems begins. 10 minutes prior to launch, about 6.5 minutes from now, the Proton steering jets will be activated as well. Here in the Russian Mission Control Center, flight controllers are ready to begin their job of monitoring Zvezda following its launch and insertion into orbit. Energia will oversee the module's operation along with U.S. flight controllers making up the Houston Support Group here in Moscow and flight controllers in NASA's Mission Control Center in Houston, Texas. For Russian and American flight controllers, the next 2 weeks will be busy watching over the activation and checkout of Zvezda's systems, leading to the docking with the International Space Station's orbiting Zarya and Unity modules.
All systems aboard Zvezda, the first living quarters of the International Space Station, will be idle as the module rides to orbit atop a Russian Proton rocket. 10 minutes after launch, the module will separate from the third stage of the Proton, and rockets on that spent stage will pull it away from Zvezda. Meanwhile, an automatic sequence of computer commands on Zvezda will order deployment of antennas for its Kurs rendezvous and docking system and for the Lyra communications system. At about the same time, Zvezda's solar arrays are to deploy and immediately begin following the sun. Meanwhile, automatic commands will order the activation of the module's major systems. One orbit later, as the module flies high over Russian communication stations on the ground, mission controllers will verify the proper activation of the major systems. Then they will command the drifting Zvezda into an orientation designed to minimize propellant usage while allowing the solar arrays to gather sunlight. On the next ground station pass, controllers will reconfigure the module's onboard attitude sensors, activate its star tracker, and test the ability of a new communication system to relay information to Russian ground controllers. Tomorrow, when Zvezda again comes into the range of Russian ground stations, flight controllers will first command it to a different attitude and later will test fire its maneuvering engines. That will set the stage for the following day's 2 firings of the module's main engines, raising Zvezda's orbit to approximately the altitude of the International Space Station. Over the course of the next several days, controllers will first test the ability of the module's motion control system to orient the solar arrays while flying in darkness, and then test the efficiency of the solar arrays themselves. They will also verify telemetry to and from the motion control system computer to ensure that Zvezda is ready to meet the ISS. A day prior to docking, Zvezda will be maneuvered to its docking orientation and its solar arrays moved into the proper docking position to verify any impact that orientation will have on battery charging. The next day, the Kurs rendezvous system will be activated, and Zvezda will become the passive partner to the International Space Station as it moves toward a docking with its newest member. With the Zarya module controlling, the station will chase and catch up to Zvezda. Ground commands through Zarya's automated rendezvous system will slowly pull the station next to the module and then capture Zvezda. It will take approximately 25 minutes for the hooks and latches on the 2 modules to fully close, achieving a hard mate and adding a 3rd module to the International Space Station. Over the following 16 to 24 hours, flight controllers will closely monitor pressure between the newly joined modules to ensure an airtight seal. And then they'll begin work to turn control of most station functions over from Zarya, its first component, to Zvezda, the future home of the permanent crews on the International Space Station.
The countdown is proceeding on schedule for the launch of the Zvezda service module just 12 minutes, 15 seconds from now. Ground controllers at Baikonur are sending commands to activate the module's telemetry system, which will relay vibration and acoustic data to the American and Russian flight control teams here in Korolyov during the Proton's ascent. Standing by at NASA's Johnson Space Center in the International Space Station Flight Control Room is a team of U.S. flight controllers watching over today's activities. James Hartsfield is there with an update from the Mission Control Center half a world away in Houston. Good morning, James, or should I say good evening?
It's a very good evening here in Houston at the Mission Control Center. Here in the International Space Station Flight Control Room at the Mission Control Center, a team of about 20 flight controllers has been monitoring the orbiting International Space Station Zarya and Unity modules. They've been on station since about 8 p.m. Central Time this evening. The team's been watching the progress of Zveda Launch activities as well. Overseeing activities tonight in the Station Flight Control Room is Station Flight Director Mark Faring. The International Space Station is currently passing over the Pacific Ocean on a southerly course through the central Pacific at an altitude of about 235 statute miles. At the time Zvezda lifts off from Baikonur, the International Space Station will be flying about 230 miles above the Solomon Islands in the Pacific Ocean. In addition to creating a home in orbit, Zvezda's launch signals the start of a cascade of station assembly flights. The teams in this room and in the Space Shuttle Flight Control Room just down the hall will oversee a rapid expansion of the International Space Station in the coming months. In fact, during the next 12 months, astronauts will conduct the most complex and difficult series of space missions attempted since men landed on the moon. Those efforts will culminate in the International Space Station becoming the largest, most powerful, and most sophisticated spacecraft ever built as quickly as the end of next year. By the fall of 2001, the station will have more electrical power, crucial for effective modern research work, than any previous space station. By that time, it already will have a volume of living and working space larger than a 3-bedroom house. And as 2001 draws to a close, it will be fully open for business, ready for the first missions dedicated primarily to research. Also by then, the end of 2001, even though it will still be less than a third of its final size, the International Space Station will already at times be the third brightest object in the night sky. In just a few months, this team of flight controllers and their partners in Moscow will be working with the first residents of the station, a crew that will bring the orbiting complex to permanent life. The exciting and challenging road from here to there begins tonight.
The launch of the Zvezda service module marks a milestone in the construction of the International Space Station, which requires over 40 flights and the addition of over 100 components to complete. In this sequence of events, the addition of Zvezda is the first time the station is transformed from a place to visit to a place to live. Assembly began in 1998 with the joining of 2 modules in Earth orbit, the Russian-built and American-funded Zarya module and the U.S.-made Unity module. Zarya primarily provided storage for supplies and fuel and station maneuverability during the early construction phase. Space shuttle crews have already used Zarya to store food, water, and other supplies that will be used by future station crews. Unity is a connecting module with 6 portholes that lead to existing and future station elements. It also houses the early communication system, which allows ground controllers to monitor the station's health and status and issue important commands. With the 2 components joined and activated, assembly continued with the addition of more hardware on the station exterior, including a Russian space crane and an American-made crane. The stage is now set for Zvezda, equipped with sleeping quarters, water, air, power, communications, and a galley. Zvezda will allow crews to inhabit the station in 4-month rotations, ensuring humans a permanent presence in space. A key event in assembly, the existing space station will be maneuvered by ground controllers to dock with Zvezda in Earth orbit. Soon after Zvezda is in place, an unpiloted Russian cargo vessel will bring supplies for the first station crew. A shuttle logistics flight will follow to unload the Russian vessel, continue to outfit the station, and transfer additional supplies from the shuttle's Spacehab module to the station. The next mission will deliver new hardware, including an exterior framework called the Z1 truss and a new mating adapter. With all